Hello everyone, and welcome to another tutorial video. Okay, so in this video we'll be treating intervals and neighborhood. Okay, that's all under point sets. Okay, so for point sets, and then we move on to intervals and then neighborhood. We won't be talking much about point sets. Okay, so we'll be mostly focusing on intervals and then neighborhood. Right, so in case you are new to this channel, I would urge you to subscribe to the channel, like the video, share, and then in case during the video or anything you don't understand from the video, you just leave those questions in the comment section and then I will reply to them as soon as possible. Now let's take a look at what we refer to as what intervals. Okay, so when we talk about intervals, we already know that intervals is you could put it in the form of what, a range. Okay, a form of a range. Okay, so from maybe A to B, or AB. Okay, could be intervals. Okay, now so for intervals we have what, closed intervals and what, open intervals. Okay, and then we have half open and then half closed intervals. Okay, so for closed intervals, okay, so let's say for closed intervals, okay, closed intervals we have let's say we have what, a value x. Okay, so we want to take the closed interval of the value x, okay, or the alphabet x, okay, within a range from A to B. Okay, so this is how we take the interval, okay, which is closed. Okay, so we have the x, okay, and then we have the x has to be greater than or equal to A, okay, and then the x has to be less than or equal to what, B. Okay, so this is how we take the closed intervals for x. Now you could either represent it in this format or in this format. Okay, so for closed intervals, this is how we represent them. So we have A comma what, B. Okay, like this. Then we have this bracket. Again, example, you could take the closed interval from a number line. Okay, so let's say we have this is how we represent closed intervals on a number line. Okay, so we have the number line. Okay, we have 0.0. Okay, that's our center, and then this is our what, 1 point. My next one, note how we draw the what, the closed intervals on the number line. Okay, it's very important. Okay, we have what, so this is something like what, x. Okay, and then we have x is what, less than or equal to 1, and then x is greater than or equal to what, -1. Okay, so this is how we represent closed intervals. Now we have what, open intervals. Okay, we have open intervals. Okay, so we have open intervals. Okay, and then for open intervals we have what, this is similar to this format, okay, but it's a bit different. Okay, so we have the x value being less than what, B, okay, and then being greater than what, A. Okay, this is how we write open intervals, and then this is how we represent them. Okay, so look at how we initially illustrated this. Okay, this is a bracket. Okay, but this is how we represent for open interval. So we have A comma B, and then what, we close the bracket. Okay, now and then in case you want to represent this on a number line, we have what, our 0.0, that's the center, and then we have what, -1. Okay, and then what, +1. Okay, now this I represent open intervals. Okay, so this I represent them. Okay, right, so you could notice that this was what, shaded. Okay, this was shaded. For closed intervals we shade them. Okay, but for open intervals you do not shade them, you just leave them like that. So this is similar to what, x value less than 1, okay, then x value greater than what, -1. Okay, right, now let's look at what, half open half closed. Okay, so from here you could have already guessed the concept behind what, half open and what, and half closed. Okay, and half closed. Okay, so this is how we represent that. So we have what, half open. Okay, so you know that open, this is how we represent open what, interval. So in case we say half open and then half closed, it means that we are closing half and opening half. Okay, so this will be what, x will be greater than a, okay, and then x will be what, less than or equal to what, b. Okay, so this is similar to what, let's say x to be what, greater than what, maybe -1, and then x will be what, less than or equal to what, 1, and then we can represent that on a number line. Okay, right, so we have our point 0, and then we have what, -1 over here. Okay, this is open. Okay, and then we have what, +1 over here, which is what, closed. Okay, right, I guess this was a bit simpler. Okay, and then your understanding was met. Okay, now let's look at what, neighborhood. Okay, let's take a look at neighborhoods. Okay, now from here you could notice that you could use any value. Okay, provided you are within the interval, either closed or open. Okay, right, now let's look at what, neighborhood. Okay, neighborhood, let's look at neighborhood. Now for neighborhood, it's similar to what, interval, but it's a bit involving than intervals. Okay, for intervals, you know that we have closed, open, and all that, but for neighborhood we have what, delta neighborhood and what, deleted delta neighborhood. Okay, so for this, how we represent delta neighborhood. Okay, so we have x minus a certain value a. Okay, and then this, the whole of the absolute value of the whole of this has to be what, less than what, the delta. Okay, so this is what we refer to as what, the delta neighborhood. Okay, the delta neighborhood, right, so this is what we refer to as the what, the delta neighborhood. Now, and then in case you want to take 2 points, okay, from here we notice that we took for a and b. Okay, so let's say we take from the left and the right. Okay, that's where we have our center and then the length. So for neighborhood, we introduce something we call the center and what, the length of the neighborhood. Okay, so from here, from this expression, we just have what, the negative delta. Okay, and that will have to be, so we are representing this in the form of what, an interval. Okay, and that will be let's say x minus a will be what, greater than the delta, negative delta. Okay, and then the x minus a will be less than what, positive delta. Okay, right, so we are representing this in terms of what, intervals. Okay, now when we make the main value the subject, that's the x the subject. Okay, that's when we are moving a to this side and then to the other side. Okay, so we have x being what, greater than what, a minus what, the delta. Okay, and then the a to what, plus what, delta. Okay, so when you move negative a over here, you end up with what, positive a. When you move that over here, you end up with what, the expression. Okay, now from here you can notice that we have our neighborhood represented in the form of an interval. Okay, for now, in case you've been able to represent this in the form of interval, all you need to know is just identify the center and then the length. And then for delta neighborhood, the center, okay, the center is equal to the a. Okay, and then the length is equal to what, 2 times the delta. Okay, keep this in mind, it's very, very important. This is how you represent both. Okay, for this kind of concept. Okay, so from point sets, intervals, neighborhood downwards, you will be applying the knowledge you learned from previous subtopic to the preceding subtopic. Okay, and so on. Okay, so you have to keep everything in mind. Okay, so this is how we represent the neighborhood in the form of what, an interval, and then the delta neighborhood has what, center of a and the length of delta, 2 delta. Okay, so the a could be, so let me write an example. Okay, so let's say we have okay, let me cite let me represent this one in number line. Okay, so that it will sound a bit understandable. Okay, so from here, from this expression, you could notice that in case you have a number line, okay, just like an interval, okay, case you have a number line, then you have point 0. Okay, that's our point 0 is the same as what? Your x. Okay, so from here we have x minus delta, and then what? X plus delta. Okay, or a. Okay, so it's either you use a or x. Okay, right. So let's say we have, let's use x as our reference because we use x over here. So we have what? X minus what? Delta, and then what? X plus what? Delta. Okay, so let's say we have x which is already 0, and then let's say delta is 1. Okay, because from here you know that x is equal to 0. Okay, and then let's say delta is equal to 1. Okay, from here note that from here x is equal to 0. Okay, x value for x is what? 0. So we have what? 0 minus 1 over here, and then we have what? 0 plus 1 over here. So we end up with what? Negative 1, and then what? 1. So this will be our what? Delta neighborhood values. Okay, delta neighborhood values. So we have what? Minus 1, and then 1. Okay, delta neighborhood values. Okay, so this will be our delta neighborhood values. Now let's take an example. Okay, so let's take an example. So an example, this might sound a bit cumbersome, okay, but trust me, it will make sense. So let's say the one neighborhood. Okay, I don't know whether you could see what I'm writing, but just follow. Okay, the one neighborhood of 0, okay, is the open interval of minus 1, 1. Okay, is the open interval of minus 1 and 1. Okay, so you've been already given the open interval. That's why initially I stated that everything you'll be learning from point 6 downwards will be just apply them. Okay, so once you learn point 6, you apply point 6 in intervals, and then once you learn intervals, you apply intervals in what's neighborhood. Once you learn neighborhood, you apply it. Okay, right. So we have what? The one neighborhood. So from here you can notice that this is our delta. Okay, one neighborhood. So from here, one neighborhood. So delta neighborhood. So we have what? Delta to be 1. Okay, the one neighborhood of 0 is the open interval of minus 1, 1. So of 0, so you can notice that our center is what? 0. Okay, our center is 0. Okay, so since we already know, we've already calculated for this. Okay, that's what we did over here. So before this question, it seems I've already done the solution over here. So since we know that we have one neighborhood of 0, it means that we have our delta here, and then we have what? Our x value. Okay, or a value, that's the center. Okay, right, and then we were able to end up with what? This open interval minus 1, 1. Okay, that's from here. Now all we have to do is just find the center and then the length. Okay, so our solution is to just find the center and the length. So for the center, you know that center is a, and then you know that this is our center, so center is 0, and then let's find the length. Okay, so the length is what? 2 times what? The delta value, which is what? Delta is what? 1. So our length will also be what? Equal to 2. Okay, right. So this is how simple this expression could be, or this topic could be. Okay, now let's dive right into deleted delta neighborhood. Okay, so this was what? Just delta neighborhood. Okay, this was just delta neighborhood. So let's look at deleted delta neighborhood. So yeah, what? Deleted delta neighborhood. Okay, so deleted delta neighborhood is similar to what? Delta neighborhood, but with some twitches. Okay, right. So for delta neighborhood, we got to notice that, or we got to know that we just have x and a, and then delta, and then you put them in the form of what? A number line, and then we represent them in the form of an interval. Same applies to deleted delta neighborhood. Okay, so for deleted delta neighborhood, we have x minus a, okay, being absolute values, and then we have what being less than the delta. And since it's deleted, we start from what 0.0, okay, right? So this I will represent our deleted delta neighborhood. Now, so once you want to put it in this form, you can go ahead and then do that, okay? You just have to expand, right? Now let's proceed from there. Now, so this is how we represent our deleted delta neighborhood on the number line, okay? So we have that, okay, and then we have our center, that's what our x, okay? We have our x. Notice that I keep saying center, okay? For the number line, I don't really mean the center to be what a over here, but per the formula, center is equal to a and the length is equal to 2 delta. But for the number line, the center is what 0.0, okay? Take note of that. Center is 0.0. Now that's the center, that I mean the middle, okay? The middle, that's 0. The center, that's the middle. Now for deleted delta, we just represent it this way, okay? So we have what delta minus x, okay, and then we have our what delta plus x. Note the difference, okay? Deleted delta comes first, okay? The delta comes first, but for the delta neighborhood, the s came first, okay? Note the difference, okay? Very important. Note the difference. So in case you have maybe x to be what 0 and then maybe delta to be what 2, you end up at what 0, okay? Then we have what 2 minus what 0, and then we have 2 plus 0, so you end up at what 2, okay, right? So let's take an example and then we call it a day, right? So we have let's take this example. So we have, in case you have any question like this, we have maybe a deleted to neighborhood, okay? Deleted to neighborhood of 0, okay, of 0 is the interval, okay, is the interval minus 2, okay, minus 2, okay, and then we've been given the same expression, okay, in the form of truth set, okay? So we have minus 2, okay, s greater than minus 2, and then s less than what positive 2, okay? Now let's proceed, and then we know that x shouldn't be equal to what 0. That's the condition given. Now, so all you have to do is just find out what our center and then what the length. Note that for deleted delta neighborhood, the center is similar to that for the what the delta neighborhood. So center is a, and then you have the length, okay? The length will be equal to what 2 times the delta, okay? So let's proceed from there. So we have our solution. So we have the center to be equal to a, which is equal to what 0, okay? And then we have our length, a length which is equal to 2 times the delta. So we have what 2 by 2, that's what 4, right? Now, so I hope this was very helpful, because I get complaints about this topic being confusing, okay? You might learn it and then you might be confused, but I think this tutorial question or this tutorial video has been able to, you know, loosen the burden of, okay? I guess so, right? So I'll see you in the next video where we'll be treating limit points, and then for limit points it's very confusing, trust me. So I'll a secret trick as to how to identify the limit point for every point set, okay, for every interval, okay? It's just a trick I use which really helped me. There's no need to, you know, go through any hassle. You just need to know that if you meet a set like this, the point set is this. If you meet the set like this, a point set is this, okay? So I'll see you in the next video. Kindly subscribe so that you don't miss out on the next video. Have a lovely day, and I will see you in the next video. Bye bye.